Alright, in this video we're going to talk about the binomial theorem. We've already talked about Pascal's triangle and using Pascal's triangle to expand binomials, if you remember from previous lessons. And you can still use that if you like that method. But this binomial theorem is going to help us find specific terms of expansions, that type of thing. So this is just a different way of going about it. You need to understand what a factorial is. N factorial. For any positive integer n factorial is denoted by an exclamation point, is countdown multiplication. For example, if you said 3 factorial, you would do 3 times 2 times 1. Or 4 factorial would be 4 times 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Some of you may actually have a button on your calculator that will do factorials. It's an X with an exclamation point. Mine is the third function. It's in green, and it's above the logarithm button in my calculator. So just look your calculator over and see if you can find the factorial button. 0 factorial is actually equal to 1. That's a rule you kind of need to know before you even start. 0 factorial is a 1. To calculate a binomial coefficient, we're actually going to calculate a combination problem. For non-negative integers n and r, with r always less than or equal to n, the binomial coefficient is defined as n choose r, or combinations choosing r. Sometimes they'll do it with a big C because it's a combination problem. Sometimes they just do it in parentheses where you have a number in top and bottom there. But it's the top number factorial divided by the bottom number factorial times the difference in the two factorial. So you can use that method to simplify the binomial coefficient. Let's try a couple just to see if we get that part. 9 choose 3 would be calculated as 9 factorial divided by 3 factorial, and then the difference 9 minus 3 would be 6 factorial. So to work that out, that would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1. So as you can tell, we can go ahead and cancel out 6 down. Also, 3 times 2 times 1 is 6. Well, I can't do that. Let me undo that. Whoops. Okay, I thought I could cancel out with the 6, but I can't do that. So we can do 2 and 1 go into, so that's 2 goes into the 8 4 times. 3 goes into 3 once and leaves into the 9 3 times. So we're going to end up with 3 times 4 times 7, which turns out to be 84. You could calculate this with a calculator. I would do 9 factorial divided by 3 factorial divided by 6 factorial, and I got 84. Let's try another one. 100 choose 98. Now that would be defined as 100 factorial over 98 factorial divided by 2 factorial. Now, you know that with 100, you'd list 100 times 99 times 98. Well, you know from 98 down, you would cancel out. So let's think about that. 100 times 99 times 98 times, let's say, dot, 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 right? Over, we know 98 factorial would be 98 times dot, dot, dot. So those would cancel out for sure, all the way down. And then 2 factorial we're also going to divide out, so 2 times 1. So we know that's going to leave 50. So 50 times 99, 4,950. Let's double check that. 100 factorial We did it correctly. Good job. All right. The binomial theorem says for any positive integer n that you're raising a binomial to the power of, and any complex numbers x and y is expanded as follows. X to the n, your coefficient is n choose 1, n choose 2, n choose 3, on down to n choose n minus 1, 1 less than your original, and then you have y to the n on the end. So your powers look like they're also descending and ascending like we did with Pascal's triangle in the same way. Let's see if we can use the binomial theorem to expand a binomial. So if we're going to do x plus y to the 7th, going back to the rule, we have x to the n, so x to the 7th. Okay, look at the next rule. N choose 1, and we're going to decrease the power of x by 1 and add the yn. So here we go. N choose 1. So this is going to be 7 choose 1. X to the 6th. And we're going to add the y into the problem. Okay. Plus 7 choose 2. X to the 5th. Y squared. Plus 7 choose 3. X to the 4th. Y cubed. Plus 7 choose 4, x to the 3rd, y to the 4th. Notice my powers always add up to be 7 as well. 7 choose 5, x squared, y to the 5th. 7 choose 6, x to the 1st, y to the 6th, and then your last term is always supposed to be plus y to the 7th. Okay, so we got to do our combinations here. 7 choose 1, and so on. So x to the 7th, we got that. Now 7 choose 1. I could look back at Pascal's triangle if I wanted to, but I'm just going to do this with the combination. 7 choose 1 would just be 7. Now, how did I get that? Let's go back over and remind ourselves how we do that. 7 choose 1 would be 7 factorial over 1 factorial and divided by 6 factorial. So we know that would be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 1, and then 6 times 5 times 4 times 3 times 2 times 1. All that cancels out. 7 over 1. So you just get 7. Okay, I'm going to use my calculator to help me do the combinations as well. So the next term, 7 choose 2, that's going to be 7 factorial over 2 factorial and 5 factorial. So that will come out to be 21 x to the 5th y squared. Okay, 7 choose 3 will be 35. 7 choose 3 would be 7 factorial over 3 factorial and 4 factorial. 7 choose 4 will be 35 again. Okay, 7 choose 5 be 21. And it's just going to go back out. So 7x y to the 6th plus y to the 7th. So much fun. This one should be a little harder to do using the binomial theorem. So let's see what we have here. It's your first, which is only to the fourth power, thank goodness, because this will be a little bit easier. So it's your first term, 2x to the fourth, plus 4, choose 1, 2x to the third, and then negative 3 to the first, plus 4, choose 2, 2x squared, negative 3 squared, plus 4, choose 3, 2x to the first, negative 3 to the third, and then the last one is always the negative 3 to the fourth power. So let's work this out and see what we can get. On the first term, you would have, I'm going to do a couple of steps here. So let's just kind of do a little bit of simplifying first. On the first one, 2 to the fourth is 16x to the fourth. So we got that, okay? Plus 4, choose 1. That would be 4 factorial divided by 1 factorial divided by 3 factorial. So 4, choose 1 is 4. 2 cubed is 8x cubed times negative 3. Okay, 4, choose 2 is 6. 2x squared will be 4x squared times 9. All right, 4, choose 3 is 4 again. 2x to the first and negative 27. And then the last term is negative 3 to the fourth, which would be just positive 81. So simplifying this down, 16x to the fourth. This will be minus, let's see here, 32 times 3 minus 96 x to the third plus 24 times 9, 216 x squared minus 4 times 2 is 8 times 27, 216 x, and then plus 81. So it's a little time consuming, but easier, I think, than try to FOIL everything or multiply everything out. This is an easier way to go about it. If you want to find a specific term in the expansion of a binomial, here's a formula. If you've got the x plus y to the power of n, it's n choose k minus 1. That's if you're trying to find the kth term of the expansion. For example, if you were going to do the fifth term, and then you would say, let's say you had x plus y to the 7th power, and you wanted to find the fifth term. So you'd do 7, choose 4, 5 minus 1. So 7, choose 4. X to the n minus k minus 1, and y to the k minus 1. So let's to do this problem, let me write that down so we can use it again. N, choose k minus 1. Okay. X to the n minus k minus 1. And y to the k minus 1. Okay, so 2x plus 5 to the 7th power. We want to find just the fifth term of that expansion. So in that case, k is equal to the 5. We just want to find the fifth term of that expansion. So we're going to have 7, choose, k 5 minus 1 will be 4. So 7, choose 4. The x part, which is the 2x, to the 7 minus 4, and the y part, which is 5, to the 4th. Okay? According to my formula, that's what we'll do. So 7, choose 4. 7, choose 4 will be 7 factorial divided by 4 factorial divided by 3 factorial. That's 35. times 2x to the third times 5 to the fourth. So working that out, you get 35 times 8x cubed, and 5 to the fourth is 625. So working that all out, let's see, 35 times 8 times 625, 175,000 x cubed. And that is